Welcome to the fourth installment of Distilled Demographics. If you remember, in the last one, we talked about the birth rate. In other words, how we come into the world. In this one, we're going to talk about a little less pleasant subject, mortality and death rates, or how we leave the world. Now, why is mortality so important? Let's just take a look at two numbers. First one is world population in 1900, 1.6 billion. Now watch what happens when we move ahead to 2000, 6.1. Did you notice those two numbers just change places? This, to me, I think, has to be one of the more significant events in human history. It's certainly way up there, when we went from 1.6 billion to 6.1 in just 100 years. And why did that happen? Sometimes people, when they call here at PRB, they ask if the birth rate rose. And the answer really is that the death rate dropped. Let's look at some of the numbers behind this real revolution in mortality, the way death rates came down. Here we see a graph of the United States, Costa Rica, and Sri Lanka. Notice that Sri Lanka's life expectancy at birth, the number of years a baby who's born can be expected to live, was but 41 back in the 1920s, and it was about 31 in Sri Lanka. In the US, the same number was about 54, and that had risen from 47 years in 1900. And just look at the end of that graph. In almost no time at all, compared to human history, life expectancy at birth, because of the decrease in death rates, rose to equal, and it's actually almost exceed that of the US. So what we see is developing countries, many and certainly not all, who have health conditions that are somewhat similar to the richer countries. One important measure in demography is the crude death rate, or the number of deaths per 1,000 population. If you remember last time, we talked about the crude birth rate, which is, yes, that's right, the number of births per 1,000 population. This is the other side. So if we note here in the Philippines, a country of about 94 million, that in a recent year there were about 450,000 deaths, which works out to about 5 deaths per 1,000 population. Now we can turn to Germany, a country of about 82 million people, and in a recent year there were about 850,000 deaths, or that works out to 10 deaths per 1,000 population. But wait a minute, what's going on here? Germany has a crude death rate of 10 per 1,000 population, and the Philippines only 5. Life expectancy at birth in Germany is 80 years. But life expectancy in the Philippines is 69. How can that happen? Well, it's really pretty simple. There's a much higher proportion of people in Germany, because of a low birth rate, who are in the older ages, say 65 and over, who quite naturally have higher death rates. So, now why are these two rates so useful, the crude birth rate and the crude death rate? Well, when we put them together, what do we get? Well, basically we get population growth, right? Births minus deaths, that's how we come and go. We're forgetting for a moment about migration. We'll just look at births and deaths, which is considered and called by demographers natural increase. So here we look at the Philippines, crude birth rate of 26, crude death rate of 5, and so the growth rate is 21 people per 1,000 population, or 2.1%. That's how we express it usually as a percentage. Now we look at Germany, which has a crude birth rate of about 8 and a crude death rate of 10. So the crude death rate is higher than the crude birth rate. So here we get what is called really natural decrease. There are more deaths every year in Germany than there are births. When a country's in that situation, population growth will decline unless there's immigration. Another thing that this rate of natural increase gives us is just how fast the population is growing and what it might be in the future. In the Philippines, an annual rate of natural increase of 2.1% will double the population in 33 years. So just 33 years, the Philippines population will double. In Germany, a minus 0.2 natural decrease will cause that country to halve in population size, cut in half in about 347 years. That's looking a little far into the future, but that's what the numbers would say. Oh, hi again. I was just reading this life table from Japan. You know, some people find numbers like this to be, well, you know, sometimes they say they're boring. But, you know, really, a life table, which is kind of at the heart of demography in many ways, really can tell us a lot about a society. So this is a life table of Japan, and Japan happens to have the highest life expectancy at birth in the world. But where does such a thing come from? Well, you know, we often call it the J curve, which is a curve of death rates by age. So here, if we take a look, we can see that in the very youngest ages, on average, mortality is fairly high. As we get into the younger adult ages, it's very low, and as we get older and older, it grows. Depending on this curve, we get a life table, and the life table, it summarizes what we've just seen in this J curve. Let's take a look at Japan. Here we have a life table for Japanese females, and I'm going to do us all a favor and just pull out a few numbers. All life tables start out with 100,000 people. That's that number in the top left. It's a round number, and it's convenient to use. Now, notice in Japan that at age 80, this particular column, called little lx, x just meaning the ages, sometimes it's called the birthday column. So that's what makes it kind of fun. Because you notice that at age 80, out of 100,000 females born, 78,000 are still alive. Imagine 78% of people living to age 80, but not everywhere. Here we look at a life table for a high mortality country, not any specific, just a typical life table. In this one, the life expectancy at birth is only about 44 years, and there are any number of countries in the world who have that low life expectancy. In Japan, it had been 86. Notice the percentage of people who survive until they're 80 in this country, 27%, 27,940 out of 100,000. So this paints a very real picture of what a society is like in many ways, in terms of health care, in terms of the prevalence of immunization, how long people can expect to live. And again, it was the transition from this high mortality life table to the very low mortality that caused the population growth that we looked at in the very beginning, from 1.6 billion to 6.1. So life tables can actually be fun and interesting to read. Try it sometime. So there you have it. Birth rates and death rates. Birth rates in the last session and death rates now. And that really describes, you know, much of how we live, how we come into the world, how we leave it. And in many ways, that shows us that demography truly is destiny.